All right, we're live. So
All
it
right.
is recording this time. Great.
All right. Yeah. Awesome. Great. Hey everyone. This is Rusty Rob. Um, that's your Twitter handle. What's your Twitter handle?
Yeah, I think it's Rusty Robert. It might be Robert King NZ. But yeah, I'm sure people can find me.
All right. Yeah. I'll put a link in the video description. Um, but yeah, we were interacting on Twitter a bit, and he's got an interesting uh, piece of software he's working on. It's for reactivity for manufacturing, uh, like data, and yeah, it's really interesting. Yeah, we'll get to that in detail, but first I want to ask Rob a bit about himself. So how long have you been developing?
Yeah, probably I'd have lost count, maybe 15 years or something. Started pretty young doing web hosting and building websites for games and stuff like that. So yeah,
Yeah, that's awesome.
done a lot. I can go through a bit, but we'll maybe try to keep it brief.
Sure.
Um,
Yeah.
yeah, got pretty into like programming contests at university. Haven't done much of that for a while, but then as I was learning Rust recently, I started posting a few algorithm videos.
Hmm.
But I've worked at a lot of startups building complicated dashboards, and then I've worked at Meta, just seeing what a big organization's like. Now
Yeah.
I'm back at the startup doing software for factories, which is really a really challenging project, but exciting, and it's still kind of in the early days, but we might open source stuff soon. So I'm starting to kind of open up a bit more about what we're working on.
Okay, that's awesome. Yeah. So like you're thinking about open sourcing, like what we're going to talk about today, or um, how much?
Like the code, like right now, this code isn't the code for this product's not really available. I can probably give people a link to the product or maybe a Tory file to that they can install because it's also a desktop application.
Okay.
And we're piloting it with some customers and things like that. But yeah, it's not really ready to be open sourced, I don't think. We're still kind of refactoring some of the foundations and things like that. And but we do want to build in the open, but then we're starting to move pretty quickly. So like I
Yeah.
don't think people could like copy it and catch up and stuff,
Yeah.
but it's always it's a bit of a balance between open source and kind of being private. And
Yeah.
we're still kind of doing the details of our business model and things. We
Yeah.
do have lots of customers and we have people that do services for factories and stuff like that. So we don't have any investment. We're self-funded. Kind of, yeah, I guess I won't go into the details of profitability and stuff like that. But yeah, it's going to be exciting to see what happens this year. Yeah.
Yeah. It's been a while since I've worked in like the startup world. I've been consulting for like a lot of companies upgrading from AngularJS to Angular. Um, we've talked yesterday. You've done a bunch of Angular as well, and you did like original AngularJS. Is that right?
Yeah, there's a startup and we built this product for education and Chromebooks. So making
Cool.
schools be able to use Google Drive, like a teacher dashboard and things. And we rode the Chromebook wave to maybe 40 countries, like millions of students around the world. We're the biggest users of Google Drive APIs around the world. It's like sometimes we'd have to slow our system down because we're like, would throttle so we wouldn't like damage their system kind of thing. But it was pretty cool. There's yeah, lots of inefficient code and lots of cool efficient code and stuff, and just yeah, it was interesting as Google Cloud came about and stuff, just seeing what it was capable of.
Yeah.
But yeah, I got put in charge of the Angular dashboard because our senior front end left and they were doing something with Dart, and then I rewrote it in Angular because Dart wasn't really gaining traction. So that was a super busy time. A lot of responsibility put on my shoulders, but it was a great way to learn Angular. And then Angular 2 came and I had to kind of relearn things a little bit. And yeah, just been building many dashboards. Each time I do a new project to kind of change the way I do things slightly, but starting to kind of get it refined a little bit. So that's good.
Yeah. Yeah. That is awesome. Yeah, I started with startups as well. It's so different from like a large company. I feel like you learn a lot faster. there are different things that you learn. Like you learn how to deal with a lot of annoying problems in a big company because you have to. There are problems with scaling, and it's a lot of non-engineering that you have to add on to it. And with startups, it just feels like, well, there's some non-engineering you have to do too because you just have to get stuff done, and so sometimes you'll have to improvise with like doing your own design work or whatever, or like, yeah. Um, so what gave you the idea to work on this like reactive manufacturing problem?
Yeah, so a guy that was my manager at a previous job kind of recruited me from Meta, and I did some mechanical engineering at university. I mostly did maths and computer science, but I was always kind of interested in manufacturing, and you see companies like Tesla and stuff, and it kind of feels cool just to not only do software, but maybe move more towards manufacturing in the future.
Yeah.
And yeah, the problems they have are pretty complicated. A website is like users are clicking and stuff. You often don't have that much data, whereas a factory, you can have data points that are doing many values a second, and even a small factory will have thousands of sensors, and larger factories might have hundreds of thousands of data points, which is like a pretty big reactive graph, I guess.
Yeah.
If you think about it from that perspective. So that's interesting.
Yeah. You hear about like benchmarks and, Ryan Carnado, I don't know, like all these tests that different reactive systems have. And I was like, okay, when would that happen? Like when would you some
Overkill.
large scale? But yeah, it's awesome that focusing more on real world applications. There are sometimes when you need to be able to do a lot of stuff. So yeah, awesome. So so you've done RxJS with Angular, like everyone. When did RxJS kind of click for you?
Yeah, I guess I started off, I had to use switch map and use the Angular routing parameters and stuff like that.
Oh yeah.
And then maybe looked at some blog posts or tutorials on Stack Overflow or whatever, saw some behavior subjects, and I'm like, not quite sure what this is, but kind of using it. But once I kind of started to get the hang of observables, and then once I started getting a lot of them and realizing, oh, they actually compose really well. And then I got rid of all my promises and my other kind of ways of doing async and just use observables. And I'm like, man, it just makes a lot of sense because each thing's defined in terms of the things that it depends upon. So it just makes the code easier to read and understand. And I almost feel like without them, it's like you get like intermediate state and things like that. It's kind of hard to tell when state is being updated and where from.
Mm-hmm.
It's kind of like in CSS when you have the Z index and you just pick a random number and hope that it's the right height compared to everything else,
when in doubt, add an extra 9 or whatever.
I guess I built my own framework before Angular came out, and I had, each thing would be like an array of handlers. So it's like, okay, call me if something happens, and then it would just do a for loop through all the handlers calling all the stuff.
Mm-hmm.
So because you always had callbacks, and I tried getting rid of callbacks and stuff like that. And I guess that was maybe similar to observables, but I guess now the way I think of it is like observables are kind of flowing down, but then when you need to push data back up, I like maybe use a subject, and then that can like push back down again.
Yeah.
Like if you have a tree going downwards, but yeah.
That's pretty much how it works most of the time. I am really interested in trying out something more like CycleJS where there is no pushing at all. It's just like you're using RxJS from event and you're getting the event from the DOM node directly. That's interesting to me. It may have happened in Angular someday. But what is needed is the ability to get component outputs as observables because it's not just a regular DOM event. And so, yeah.
Sounds tough. I feel like we have a similar problem with factories where right now we're reading all this data from factories and it goes into insights and all these other systems. But from those insights, people want to push back into the factory, and you might like want to modify how the machines are doing so that they, with machine learning, they get smarter. So kind of having gradient descent flowing through the factory or something. And when you start pushing back down into the factory, it's kind of like, is that an observable? Like, can you use like from event for that? Like, if I'm trying to compare it to like Angular World or the browser, it's like that. Yeah, everything's a lot more efficient when it just flows one way, like out of the factory. But once I start sending stuff back in, and then that's causing all this stuff in our expression engine, maybe I can only push back at a certain rate. I don't want to like push back too quickly. But it can be basically the same set of principles, but maybe just not at such a high rate. It might cause performance problems.
Yeah. So do you wanna walk through the reactive thing you have?
Yeah, I'd love to.
Software.
Cool. So I just pulled some changes and cleared out my database and stuff. I'll just share my screen. So I'm hoping I don't come across any bugs. Okay, so is that Cinema Vision? So can you see my screen?
Nope, I cannot.
I need to click present.
Okay.
But yeah. Okay, share screen. Okay.
There we go.
Do you see my tabs and stuff as well, or you just see this product?
Well, it might be recording the tabs, but I see just a black bar at the top.
Okay. Yeah, I was going to I've got Excalibur on another tab if we need it, but I think I might need to share that separately. Anyway, it doesn't matter.
Okay.
So this is like an IDE kind of inspired from VS Code and WebStorm. So you got, and it allows you to build like a reactivity graph in a sense of all the sensors in your factory. And then the idea is you can build expressions that run when those data points fire and bring all the data together and make the snowball of insights, which you can then send into a data lake or something like that.
Okay.
So the first thing you want to do is create I guess if I go to this, I can, so you have functional locations, which is like, I'll create a functional location first, I guess. Yeah. So let's just say I've got like a company called Tesla. And then within Tesla, I might have like let's just say, we'll skip this site. We'll just go straight to the line. Let's just call it like a press or something like that.
Okay.
And then I might have something else like, let's just call it a machine, like, I don't know, painting machine. And then if I can do that, so you can see I'm kind of building up a tree of locations. And then within each area, we're going to create like data points and things like that. So when I create within the press, for example, if I want a new data point, I could have various types of data points, like something from an MQTT broker, something that's polling IT systems or other systems. We want to bring as many systems together as possible. You want to be able to query databases. So we've got like things like cron jobs and stuff that are running. But I guess the best one would be like an MQTT broker. So let's create a connection. I thought I already had this created, but I reset my database. So localhost, and test if this is running. Yep. So I'll save that. So we've got a connection, and I can make it an output if I want. If I want to like output data or the result of expressions to that. We won't bother our outputs for now.
Okay.
And so let's just see what a data point is. So it's kind of like an observable. So it's just a place, like a sensor, where data comes from, but not necessarily a sensor. It could be like a computer, or it could be some image recognition that's emitting different data points. So we'll create a new data point, and let's just say, what should we call this? Create car, for example. And we'll just make the topic create car. So for those that aren't familiar with MQTT, it's kind of like pub sub. So think of it like your post shop, where you send a letter to them and then they can send it out to someone. So, and if I'm interested in what someone over there is doing, instead of me asking them, has anything changed? They can just write on a whiteboard, and I can just look at their whiteboard. So whenever something changes, they write on the whiteboard, and anyone that's looking at that whiteboard can kind of see. So you can get many to many, one to many, many to one, and so on. So it's pretty good for factories. So we'll just say this is a number.
Okay.
So now you can see within the press, we've got that data point. So I can
kind of looks like a signal icon, like
I'll close all these tabs.
Angular signal, whatever.
Yeah. So in our press, we've got this create. So you can view different locations to get more granularity, especially within large factories. It's pretty important.
Yeah.
So this data point, it's not that exciting. You can edit it, but you can view the data. So if I open my MQTT editor, don't want to update. So let's connect to this broker. And what did we call it? Was it create car? Was the topic. And value of 2. So if we send that through, yeah, it's come through. And I can send through a few of these. So it looks like we've created 6 cars. So production's going pretty well so far.
Yeah.
So that's the data point. And then to get more interesting, let's just see the total amount of cars we've created recently. So I can create it from the left-hand explorer. I can just create stuff in here as well. So let's create an expression, and we'll call that total cars, and that can be a number as well. We can shuffle that, or if you want, you can kind of move stuff around. I know this is more about reactivity, but it's cool having the visual editor as well sometimes.
Yeah, actually, like the visual editor. I think that maybe reactivity might be a great place to have visual programming, because, and I mentioned this before, but that you have, like, with the imperative model, you have a function that's calling out to multiple pieces of state and updating, and so everything is organized by when it's executing. And then in reactivity, you have multiple independent states listening to an event, and so they're like symmetric, but they're like backwards, and so it's the reactive side is organized by what it's relevant to, but it's nice sometimes to be able to see both, like what is everything that happened, what is everything downstream from this data source, and also what is everything that's being that's affecting this state. And with visual programming, I think it's easier to see, because with code, like words, text, you get the variable name, and so that's the reference. And then with visual programming, you can have like a line between them, or some visual connection, and it can be faster, I think. But visual programming just never really catches on. Except the exception that I've seen is LabVIEW, which this is very similar to, but it's more archaic. Like the UI is kind of terrible, but it's still a really cool thing. And people, physicists are using it. I don't know about other places. I used it in college doing physics, but yeah. So this reminds me of LabVIEW, like a better looking LabVIEW. It kind of does look, like it's
I'll
still
brush
early
my
days.
shoulders off there. We haven't got a designer yet, but
All right.
yeah, I've just been doing the design myself so far. I haven't actually chosen the colors I want yet, but it's looking alright. It's functional. Yeah,
Yeah.
I agree. I feel like the granularity of files is it's good to have a file that's maybe like 100 to 1,000 lines long, and you can kind of read top down, kind of build a picture as you're reading top to bottom.
Mm-hmm.
But with reactivity, it's like you have lots of small. It's nice if each reactive thing is quite small with not too much logic, and it's more about having clear names for each dependency, and then you can understand things based on the description of its dependencies.
Mm-hmm.
And files aren't really granular, and they're a bit harder to make, and you get too many files in your exploratory and stuff like that. So that's one of the challenges, is just thinking about how to lay all the stuff out. What happens in large factories is you get a lot of cruft because people create different values, tags, metrics, and so on, and then other people don't know about them, so they recreate them. And every time they just create a new database table, and because you can't find stuff, you get all this cruft, and yeah, it's like there's no way to really fix it. So we're hoping, as part of this, it's not just a reactivity graph, it's more like a knowledge graph where you can have like processes, you can have people, like all different things in this graph. But today we'll just focus on reactivity. But we want people to kind of document the factory, almost like a digital twin of the factory, where different people can come together and have common understanding. So it's not like information silos and all these different systems that only people in each area can access. And like here, it's like anyone can like ask questions and get insights straight away, which can save them a lot of money. You don't have to wait weeks for different people to give you the information you needed, and then it's like, I'm done. Because yeah, factories are so dynamic. You can kind of rearrange things in the factory and get completely different results. You send through different orders, all kinds of things are happening. Each production line could be working on like multiple different orders at the same time and things like that. So it gets messy.
Yeah, and if your example is Tesla, if I actually work for Tesla right now.
Oh, really? Cool.
Yeah, consulting for them, but I don't know anything about the factories except what I've heard from YouTube channels. But yeah, apparently it's like really dynamic and things change really fast. So if that influences the industry more, I think like a software like this is going to be really critical, because it could get messy. Yeah, I don't even know if Tesla has their own software to manage this.
Yeah.
I don't know anything.
Yeah, you should hook us up with Tesla as a client. Would be happy with that. I'll give you like 10% of the sales. Yeah.
Well, I'll ask my manager if he knows anything about like this factory software.
Yeah.
Yeah,
But yeah, we're starting smaller with like smaller factories, and I want it to work comfortably for like maybe 100 data points or something like that. We're keeping in mind like 100,000 data points or something. So like, I want everything to be ON algorithms and just fast reading. And like we kind of want durability for longer term data, and so just making sure we use like a write ahead log where we can like write that really quickly, but then we can also like put it into more efficient data structures at the same time and things. I guess I won't go into too much detail about that side of the system, but maybe I'll go talk more about the reactivity graph. I'll go back to sharing my screen.
Okay.
I'll just go back to, how do I do this? Is that my screen now?
Yeah, I can see your screen. Yeah.
So we're trying to make the total cars, right? So
yeah.
So I'll go to that tab. It's quite nice having tabs because you sometimes forget where you were once you're creating a bunch of things, and it's like your short-term memory is in the tabs. So we want to edit the parameters, and this is where, so we add that as a parameter. I can go to different locations, jump through, and like find things. So I can have things from outside of this location coming in.
Oh.
It just means it's kind of interesting. Like, in Angular, when you like move a component around, like
Yeah.
a child component, and it's got inputs then that are observables, then all of a sudden that parent component has to have those observables as well. So it's like broken until you wire things back up.
Mm-hmm.
This is kind of exactly the same. Like if I move this, say this press was outputting total power used to like a power meter for the factory or something. If I move it to like another organization or something and they don't have a power meter, then it's like, where's that going to output to? Or same with things flowing into it, So it's kind of interesting in the boundaries. And when I could like delete this whole press, and it would that would cascade delete it. But any edges that kind of flow outside of that, like outside or inside the press, will not be deleted. And so it's kind of like tree shanking, I guess. But anyway, so if you missed that, I just added this edge here. So that means every time a car gets created, the total cars will get how many cars were created.
Awesome.
And so now it's complaining because this data model here, it expects a value and a timestamp.
Okay.
So I need a value and a timestamp. Cool. So now it's happy. But let's also just call this count, this here, the alias. We could have multiple create cars coming from different lines and stuff. That's why we always have an alias. But let's just say let total equals 0. And then let's say for, I don't know, let's just call it count objects. Or let's just call it like payload. I can't really remember what this is. Of p count dot. So let's just go recent payloads. So we could get the latest one, recent ones, or like ones that are unprocessed since last time this expression executed and things like that.
Awesome.
And we want to make that a lot more powerful. And also the expression engine, based on what you're using, could be a lot more efficient based on like how many recent values of each data point or expression it saves. But it's kind of like the consciousness of the factory, I like to think of it. And it's like all like DQs and stuff like that. So like popping and pushing and things like that. So total plus equals payload dot value. That was just the count that we had. So let's just return that total. And if I go view data, no data yet. I also note that I've got this text, so it's like a driving input. So whenever something happens with this data point here, then this is going to execute. And that'll make more sense once we have more parameters coming into this, and we're like building more of a proper graph. So I could click run here, but let's just try send a car through. So I think the answer should be 8, right? I can't really remember how many cars we got. I just got to connect.
I don't remember.
So there we got, 8. And
awesome.
we could also see like a chart of this
value.
And it says 8, and then I don't know. It's hard because I don't have enough screens here. Anyway, you can see the counts going up, and I could go like 100 cars all of a sudden got created, and then
And the x-axis that's because you hard coded the timestamp.
So this is more just for kind of debugging and stuff like that.
Oh.
The x-axis is just one after the other for now. Okay. But we want people to be able to choose based on the payload what the x and y axis are and stuff like that. But this is more just for debugging and playing around with stuff. But you're supposed to send this to like a data lake or to other systems where you can kind of analyze stuff better.
Yeah.
And we also have like logs and stuff like that. And so just was thinking just quickly, I might add one more data point here, like rejected cars, and then we could look at like quality. What do you reckon? If I do that quick, how are we going for time?
Yeah, that sounds interesting.
So reject car. That can be a number as well. I don't know what keeps doing that. I need to fix that. That kind of irks me a bit. So now we just go back to total cars. Actually, I'll rename this. Rename. We'll just go like quality. Let's clear these values away. Clear that away. And so now we'll just edit the parameters. We'll add that in. Just copy this. Reject total. Let's call this. And there's some other kind of cool stuff here where like it automatically reruns the language service. So like you get compile errors straight away.
Oh,
when
cool.
you change it. And if I change the data model of like any of these inputs, then this will all update straight away and stuff like that.
Okay, and the driving input is that like having like a combined latest versus like a with latest from, or yeah, you mentioned you were maybe gonna explain more about that.
Yeah, so for some things, yeah, it's kind of like with latest from basically.
Okay.
So often there'll be like a defining moment when you want to calculate something. It's like, okay, every time a car was created, I want to look at all these different things. Yeah.
Okay.
It might be like at the end of a shift, I want to know what all the things that happened in that shift or something like that. There's a lot, yeah. And so it also makes the reactivity graph more efficient, and it makes you only send out kind of values that make sense.
Yeah. I don't know if this is something you would run into with manufacturing, but you do know what the diamond problem is? The diamond problem of reactivity?
Yeah, so we could try that if you want, but yeah, it's glitch-free execution or whatever, because it does like a topological sort, and it so actually, can you see this screen, this Excali draw here? I'll switch back to screen actually.
I can't see it.
Let me share screen. Okay. So this one, for example, can you see that?
Yeah.
So yeah, we would just count how many arrows come into each node. So it'll be like 3. This one's got like 1 coming into it, 1 coming into it, 0 and 0. Okay. And so yeah, right now their code, they can't return asynchronous code. So they can't really do database calls within an expression because it could slow down the expression engine, which we want to run really quickly.
Yeah.
But we have some ideas around being able to do that. Other things can still run as long as they're not all if this thing's really slow and this thing's really quick, and then this thing over here is going to get slowed down because of the slow one.
Yeah.
So yeah, I guess you can be slow as long as you're not holding other things up. But basically, we would see that these ones have 0, right? 0 in degree. And so they are like the starting points. So these would execute in parallel. And then it's like, okay, now this one goes to 0 because its parent's been processed, right?
Okay.
and this one would go to 0 as well. And so basically then these ones would execute in parallel, and then this one would execute. So even if also, it also depends, like if these two expressions fired in the same batch, if these two data points fired in the same batch, or if they fired separately. Like if this one fired, then it would trigger this one, these two, and then it would trigger this one.
Okay.
And then this one fires, and then this one would trigger again. But that depends what your driving value is, right? Like we're assuming all of these arrows are like driving.
Uh-huh.
But if like say this one wasn't driving this edge, then when this one runs, this one wouldn't trigger. So yeah.
Oh, cool. Okay, that is awesome.
And
yeah, this reminds me of signals, but I don't know if you have, like in SolidJS, if you have that ability to have like a non-driving input into a signal. Okay.
yeah, it's kind of interesting because as they're building the reactivity graph, we know the entire graph. It's not like a dynamic graph. We can
Right.
like every time a user makes a change to the reactivity graph. It's not like a UI where you kind of have to quickly respond to things. So if you like change something in this graph, I could take like half a second or a second before I even update this whole graph.
Mm-hmm.
So I could like, have a task that runs every second just to update the reactivity graph, and then the expression engine, when it does like a run, it'll get the new graph kind of thing. So everything's kind of consistent.
Okay.
But you can do a lot of optimizations because you know the whole graph. Like you can decompose it into connected components. So it's a whole lot of smaller graphs, and you could even do like max flow algorithms to work out like bottlenecks and like break it into like further. You can work out like the minimum cut and break it into smaller pieces and stuff like that, which is pretty cool.
Yeah, awesome. So and so you have like derived values, and so one of the things that people are confused about in reactivity is the difference between effects and like the template. But like people who watch Ryan Carniot's streams, we should know that it's that the template is an effect, and like the effect in an Angular as well, like the effect function that we're getting is uh it's for like random stuff, but it's similar to template. And so a lot of people think that side effects have to be imperative, and we just have this effect that takes a callback function for imperative stuff, for miscellaneous, like whatever effects we can think of, but it doesn't have to be imperative. If like we create like a wrapper or something, SolidJS has the compiler that creates the effect that updates the DOM nodes. It doesn't have to be imperative. So with this system, these are all like computeds basically, but you have like the sources, and then you have or signals, whatever, and then you have like computeds. And where do the effects come in? And is there a difference between, like, are there any special effects, or is it all pretty much you have like sources and derived values that may or may not be saved somewhere?
Yeah. Yeah, right now everything's just saved. Like it kind of, you get your data points that have changed in this batch, or you kind of like if two data points kind of affect the same value,
Mm-hmm.
and one comes before the other with different timestamps or something, then like one of them has to run first to kind of make it not glitchy, and then so you have to run the expression engine twice. But sometimes sometimes you can just run the expression engine once. But
Okay.
yeah, like effects, I guess we don't really have effects, I guess. It's kind of like after all the values have updated, then we send them in a batch to your outputs, like your time series databases and your brokers and things like that.
Okay.
We get things like errors or like skipping, returning, and things like that. Um, it would be cool if you could affect things within the factory or something. Um, that's one thing that's interesting is a lot of factories, they'll want to run everything within 2 milliseconds latency, because if it's like more than that, say you've got like a laser, something is moving, a board's moving along, and you want to cut it in the right spot. If you've got more than 2 seconds latency, it might cut it in the slightly the wrong spot. So there's just more you can do if it's quick. But then there's also things kind of like browser animations where like you have like a little control system there that kind of, the render animation frame or whatever. It's like it basically, you're just controlling at a higher level every 2 milliseconds what it should do, but then it can do things at a faster rate. But yeah, I don't think we have effects.
Okay.
Not yet.
But you do pick like what the output of the data is, and that's kind of an effect, but it's not like a custom effect. Maybe you just like configure the output, and it like saves to a database or whatever you want, right?
Yeah, I'm trying to think of an example. Like maybe, let's say I wanted to do, I swipe my bus card. No, I swipe my train card at a station. I tag on, and I get off and I tag off, and I want to calculate like how much did that trip cost. Then, the first data point would emit, okay, tagged on, and then the other one would emit tagged off. And so when on the tag off, I'll have an expression, and then it needs to have my user ID and then it has to be able to find when I tagged on to calculate the cost.
Mm-hmm.
So in that case, it's a bit more complicated. It's like you need like a data store or like a cache or like some context, some like global state for that. Which right now our system can't do, but I'm probably going to work on it soon. But I guess you could calculate the cost and then you could remove those from that cache. So it's kind of like an effect, maybe. Now that I think about it. Yeah. So.
Okay.
But yeah, I'm not sure. It's interesting. I'm kind of talking to you. I'm getting at lots of ideas here.
Yeah, I love analogies. Like analogies, some of them really don't make sense, but honestly, most of my ideas just come from analogies. But the more random the analogy, the more weird the ideas, and sometimes that's a really fun source. But it's kind of a reactivity system, so it makes sense to compare it to signals or observables. It's not exactly like signals because you have like the driving input stuff, but as far as I know, I'm not like super familiar with signals yet. But yeah, cool.
I was just thinking also, it would be cool if we had RxJS observables and signals and all the different reactivity frameworks in here, so you can use any of them. It just depends,
what people want.
Yeah, and it also depends. We need metadata to be able to display things in the graph. Like we need an XY coordinate. We need to know the name of the node, the icon, things like that. Depending on if you want to be in the knowledge graph, you need certain abilities or strategy patterns, which are like TypeScript. There's like some TypeScript abstract classes. So based on where the node needs to be rendered, this has like different context menu options, and it might be drag and drop. It might be, this or that. If I just share my screen, the knowledge graph quickly, maybe if I create like a bigger factory. So I've just created this demo factory. So I could create a few. Yeah, it would be cool if you could see observables in here, like RxJS, or if you could see signals. Maybe you could just have some black boxes in here where it's like stuff goes in and stuff comes out, and it has to be like a data point on either end, or like it, So I feel like we could have lots of different reactivity systems in here. We're not really with Tori, our build's pretty small. It's like less than 100 megs, maybe like 50 megs or something. But it'd be fine if it was like 200 megs, 300 megs. We could add so much as a desktop app.
Yeah.
We can do a lot. But if you're wanting to run this in the browser, it depends where you want to run it. And right now, it's kind of, we can also do code generation. So it can kind of generate something more efficient and smaller that you can use in different places and maybe extend it that way. But yeah.
Yeah.
See.
Yeah, this is awesome.
I could make a massive as graph if you want to see if it blows up or not.
Sure. That sounds fun.
I'll delete all this stuff. So I'm hoping when I delete all of this stuff, it'll close my tabs. Yeah. That was kind of hard to do, by the way, just because the cascade deletes automatic and then it's like, I don't know what got deleted. Okay, so I go to my APIs. And then I'll do a performance test. So I'll do like one data point. And then, yeah, we want to give people API access and stuff to this as well, so they can hook into it.
Oh, fun.
Let's just do like 1,000 expressions. So that's created. And if I just refresh this and shuffle that, there we go. So
wow,
1,000 data points, and I've run it, and it updates them all within a second with durability. So I was pretty happy with that, and haven't really optimized that.
That's awesome.
But yeah, we're not really expecting people to build such big graphs. Like it'd probably be like 4 or 5 deep. I don't think we'd go deeper than that, you know.
Yeah. That's pretty awesome.
I'll see if I can find. So this is like, yeah, 993, 997, and so on. And then, and obviously you'd probably want more locations than this.
Okay, yeah. There's the one source
data point. Yeah, I could try running it now, but yeah, that's all right.
Yeah, that's cool. What are the lightning icons for and the connections?
That's if it's a driving input or not. So it's like a trigger. Yeah.
Man, this is awesome. So I assume like as you continue developing this, or like what are your plans for if you do? Well, you probably don't. It's still pretty early. I think we already talked about like the open source side of it. But like, what if somebody's like interested in this? What should they do?
Subscribe to my YouTube. I don't know. My DMs are open on Twitter, and yeah, feel free to message me. I think it'll probably be at least a few months before I'd give people the code. But yeah, I was also thinking like if this should be used beyond manufacturing for just, this is kind of like Excel. It's like the next version of Microsoft Excel or whatever. You know how you have like the spreadsheets where you have all you can do tabular stuff and like one cell updates to the other and stuff.
Yeah.
Like with this, it would be cool if I could turn it into like a world of data where, well, basically I forgot to mention this knowledge graph I showed you. It's actually just a small part of the bigger picture where you can connect these up to each other as well. So people making proprietary machines within a factory could have their own this product running, and then through a broker you could have this product running at the factory level, and it could connect to that, and then at the company level you could have all of your different sites sending insights and things like that. But then I was kind of thinking, yeah, maybe you could have like this open data network for the whole world, like where like people could use it at home for like to control the smart homes and stuff like that. And then yeah, it'd be cool if yeah, people. I'm sure people would find all kinds of crazy ways to use it. So and that's part of the reason we didn't really use RxJS straight away. Like we do use RxJS with our Angular development,
Mm-hmm.
but um, we want this to be usable by anyone,
Mm-hmm.
like control systems engineers and things like that. We think TypeScript will help them, but when they don't, it kind of does code generation as well, so they don't necessarily need to create the functions themselves. They can just write stuff within it, and it will hopefully give them sensible error messages.
And then they can put like TypeScript developer on their resume.
Yeah, for
Yeah.
sure. I'm interested to see what happens with TypeScript and Rust. Like I feel like I've been lucky. Every language I've picked has ended up doing pretty well. So like I used Python, and then that got popular.
Yeah.
Then I used like Go, that got popular. I used JavaScript. Then TypeScript and Rust, and yeah. So like all the languages I've used have kind of gone way up in popularity over the years. So I guess maybe I pick and choose projects carefully based on what I want to learn as well.
Yeah.
But
Yeah. I mean, Rust, I mean, I keep hearing about it, and I did look into it a bit, and to me it seemed like a really solid language that I hope catches on and or like gets more and more used, because it would, I think, in total, more apps would be more performant if more what stuff was written in Rust. Um, but yeah, I'm not sure. Like, there's a part of me that wants to go back to like my physics uh, background and maybe try working on some computational physics or something somewhere. Like maybe try to work
cool.
in SpaceX or something. But
Yeah.
uh, I'm wondering like if they use Rust. Like, do you know? Like, you probably do. Like you, Rusty Rob. That probably comes from Rust.
Yeah, I know a guy in New Zealand also called Tim, and he wrote a book on Rust, and he's pretty well connected with who uses Rust and things like that. I feel like a lot of the companies are adopting it. Facebook's or Meta said that everyone should start doing their scripts with Rust and start using Rust for things. You can see a lot of big companies have joined the Rust Foundation and sponsoring it and things like that. So seems pretty good.
Yeah.
And then Rust seems pretty good for like WASM, and it can compile down in similar ways to C++ and things. So it kind of is good for like browsers and stuff.
Awesome.
But yeah, have you seen that? You're talking about computational physics and stuff. Have you seen that Lex Friedman podcast with Wolfram? There's been
Oh
a
yeah.
couple of them. One came out recently, but yeah,
Yeah.
you'd probably love that.
I listened to it last night while I was mountain biking. Yeah.
Cool, cool.
Yeah.
Oh man, I do mountain biking as well. So if you're ever in New Zealand, let me know. You could go for a mountain bike. But
I should,
yeah,
because like right now I'm staying in Airbnb, so I can try new trails, mountain biking. I love trying new places. So maybe
cool.
I can
Sounds
like,
like the life. Whereabouts are you? Are you in America?
yeah, I'm in Utah. Um,
Oh man, I've heard that's awesome. Yeah,
yeah, I was in St. George, so like southern Utah, and mountain biking a month ago for like 2 weeks. Uh, yeah, it's been awesome. The last month has been awesome. I should have done this a long time ago. But yeah, like at some point it would be fun to try other countries, but um, New Zealand, yeah, you probably have good mountain biking down there too, huh?
yeah, it's pretty good. Actually, when I was at the Google I/O conference once, I met someone from Utah. He's like, "Oh, you should come work in Utah for 3 months. We'll like pay you, and you can go like rock climbing and mountain biking and stuff." Sounded pretty cool, but didn't work out. But it would have been awesome. Yeah.
Yeah. If you ever do end up coming up here, yeah, it'd be fun to go. Um, yeah, yeah. Speaking of Google I/O, people who watch my channel might be interested. They mentioned state adapt in the talk about Angular signals. Well, they didn't mention it. They just have my icon there, the icon that I designed, with my
Oh,
full
awesome.
design skills. Just because they've been talking, the Angular team has been talking with state management people, and I was part of that, and I'm not entirely sure why, because state adapt has like 120 20 stars right now on GitHub, and it's like downloads are like less than 100 per week. So, I mean, some people are using it, which is great, but I'm kind of wondering, like maybe it's all because of the article I wrote about like Angular needing a new reactive primitive. That's probably what it was. They like that, and they're like, or maybe they had like 4 icons and they needed a 5th one for the slide and they're preparing. So because the NGXS one is just NGXS spelled out, so it takes up a lot of space. So maybe for design, slide design, they needed my input.
Yeah, I went for like a long time just using RxJS, and then tried it Rx Angular, and I was like, okay, this helps. I guess I kind of got put off a bit by Redux early on. I was like, oh, yeah, I can see the inversion of control, but it seems like overkill for what I need. Like I managed to do everything with just pretty simple observables, but now I'm like, actually, it's nice having some structure, even if you just have all your actions in one place and you have your effects. And yeah, I think it can reduce boilerplate and make things a bit more readable and things.
Yeah.
I've read through the documentation a bit of State Adapt, and maybe could use it at some point.
Yeah, I should. I should. If you're interested at some point, kind of give you a walkthrough if you want. But yeah, Arcs Angular is. I mean, that's probably my top choice right now. I was waiting for State Up 1.0 to come out before recommending it to people. But still, I would recommend it to people for like startups. And honestly, like it's so interesting how emotionally invested I am in it. And anytime somebody mentions it or asks a question to me, it like doesn't matter. Like if I just it's like in the middle of the night and I see it, and I'm like, I want to answer. I want to answer that question. So yeah, maybe I'll burn out eventually, but it's been like a year and I'm still like, so I wouldn't, I don't know. It's it's still good for like experimental projects for sure, like it was before 1.0 came out. And it's like I've tested in a lot of projects. So I mean it's fine. And I haven't needed to fix anything. There was, yes, 2 people fixed typos in my docs, but like nothing has changed in the core since I released 1.0. So it's probably like there's a good chance the first couple of people to use it would get a lot of like free consulting from me. And after a while, I don't know. I've never really run an open source project before, so I don't really know how this is going to go, but it's gradually growing, very, very gradually. So yeah, we'll see.
Yeah, and it works for Angular, React. Does it work for Quick, Svelte, and Solid? Not Svelte.
Quick.
Not Quick.
For Svelte and Solid.
Yeah.
But Quick is its own thing. Quick, ArcGIS isn't really great in Quick.
Okay, because of the resumability. Yeah, it kind of, I guess you can't access some of the internals.
Yeah, the Angular team is interested in resumability. That's what they've said, like publicly. But who knows? It's a tough problem, and but I think that it is. I bet they can figure it out, because signals, I think, are like the key, because you have the information about what needs to change, so you should have the information about what code needs to be sent to the client, or even not sent. You can just whatever. I don't know. I'm optimistic about it, and so I'm thinking about alternatives to ArcGIS, for like built on top of Signals, because I tried to make ArcGIS working quick, and it's really difficult. But to make Signals more like ArcGIS, that's what I'm interested in. So you can do like declarative async code more. And so I don't know. It's one of the questions I want to ask Mishko about. I'm really interested in asking you a few questions about Signals.
Yeah.
And yeah.
Yeah, it'd be good. I hope we get to talk to him next week. We should do. I wonder if like a signal with multiple values can represent multiple observables, like if you're using like filters and things like, for example, like the VM people use where you have like the error state. So it's like error, or you've got data to show, or you've got loading state.
Mm-hmm.
So that could be derived from like one observable, which is like it starts off loading and then it either gets an error or it gets a value. So that's kind of like an observable, but then in the template, it's kind of like maybe you could just have a single value each. So you could have like two values, like it could come through with like loading and error equals null, value equals null. You know what I mean? And then it comes through with like loading equals false, data equals the data, and error equals null or something. So it's like, yeah. Whereas like signals have to start off with a value, but start off with like loading. Anyway, I think I need to write this out or like draw a diagram or something.
The basic idea is that you got to represent events as state. That's the challenge because everything has to be state with signals. Because there's always a current state and you always replay state when a new listener subscribes. But with ArcsJS, it's kind of implicit. It emits a value, and just the way it's wired, it's treated as an event. So, yeah, I'm thinking about this. I need to think about it more, in case we do get to talk to Mishko, and because I want to get as much as I can from that. But anyway, thanks for doing this and presenting this. It's been really interesting. And
cool.
if you I'll put your stuff in the description. Just send it to me. I have your Twitter handle, but like your YouTube channel, I'd probably find that too. But you probably do content about Rust, and maybe in the future you'll be doing more about this kind of stuff.
Yeah, I'm keen to do some Angular and TypeScript stuff as well, and maybe just some visualizations and things like that. But that sounds great. And thanks so much for your time. I really appreciate it. It's cool having like someone technical to talk about these things with. And I think every time you talk about these things, you get more ideas and kind of move in the right direction. So thanks for that.
Yeah, awesome. Yeah, that was great. Yeah, thanks.
Great. And recording.